Alright, so I think this is recording. Let's take a look. We're looking at skill packet 5, exponential and logarithmic functions, and in skill 5G we're solving equations, and here in problem number 6 we have an exponential equation. We want to solve it. On the we're going to have to know our properties of logarithms and the definition of logarithms to do these problems. On the left hand side I see two terms. The term that's of interest is the term that contains my variable. So I need to get that term by itself, so I need to add 1 to each side of this equation. So I've got 3 times e raised to the 1 minus 4x is equal to, well, if I add 1 to each side, 4 plus 1 is 5. So now on the left-hand side I have two factors, and it's the second factor that's of interest. It contains my variable, so I need to divide both sides by 3. So since 3 does not divide 5, we just write it as 5 over 3. Now, I need to get this x, it's up there as an exponent, I need to have some type of property, some type of way to pull it down as a multiplier, and that's where the properties of logarithms kick in with the product rule. And since base is e, this is one time that I'm going to take the natural log of each side. It's going to have an advantage over the common log, just because you'll see that when we this e raise this power and the natural log of e, because they're inverses, we can immediately write this as 1 minus 4x. So if I take the natural log on the left hand side, then I have to take the natural log of the right hand side to balance the equation. And like I say, I know that this natural log is base e. Well, when this base and this base are the same, that I get this input of 1 minus 4x on the left hand side because they're inverses. If I don't see that, I can use the product rule. I can pull this down as a coefficient, and 1 minus 4x times the natural log of e. And here again you've got a base of e. E to what power is equal to e? E to the first power. And the calculator can even tell you that. You can even take the natural log of e to the there, and you can see that it's 1. But anyway, hopefully you can just see that it's 1 just by looking at it. Alright, so on the left hand side we've got two terms, and the term of interest that we want to get by itself is that 4x, the negative 4x. Let's subtract 1 from each side. So we've got negative 4x is equal to negative 1 plus the natural log of 5/3. So to get the x by itself, now it's two factors, and the factor of interest is the variable, so we divide both sides by negative 4. And we've got this numerator divided by this negative 4. Alright, so let's go and plug that. That's an exact answer. Let's go and plug that into a calculator to get a decimal approximation. Divided by negative 4. Alright, so I get 0.122. Let's see, is it easy to plug in? Yeah, it's easy to plug this in and check. How good is our approximation? So it should be close to 4, and it is. If we what? Oh, well, I was going to point something out, and I can't pull it back up. Anyway, that's my answer. So let's move on to the next problem and see what we have here. So I can actually write this one with the same base. So although logarithms will definitely work, we can rewrite. Let's do this problem two different ways. Let's rewrite the 8 as 2 to the third. And let's rewrite 1/4 as 2 to the negative 2. And when you have a power raised to a power, you multiply the exponents. So 3 times the 3x is 9x. And distribute the negative 2 through, and we have this. Since these exponential functions are 1 to 1 and the numbers are the same and the base is the same, why these exponents must be the same. And if we add 2x to each side to get, we've got on the right hand side 2 terms that has the variable, on the left hand side 1 term that has the variable. We need the terms that have the variable to be on the same side of the equation. If we add 2x to each side, we get 11x. That single term here has 2 factors. The second factor is the one of interest. So 10 over 11 is the answer that I'm getting, and we can easily check that in a calculator. Now, let's illustrate that we can get this same answer using properties of logarithms. If I did not recognize that I can rewrite the base as the same, I can take the common log of each side, and I've got the log. Take the log. Alright, so now this exponent and this exponent, but by the product rule, come down in multiplication. So I've got 3x times the log of 8. I've got x minus 5 times the log of 1/4. I need to get the terms that have the x on the same side of the equation, but first I need to apply the distributive property. This binomial, this first term, it gets multiplied by log of 1/4, and the second term gets multiplied by the log of 1/4. And so now I've got it written in terms, and I need to get the terms that have the x on the same side of the equation, and the term that doesn't have an x on the other, so I'm going to leave that one there, and I'm going to, this 3x log 8, I'm going to leave it alone. I'm going to subtract x log of 1/4, and that equals negative 5 log of 1/4. So on the left hand side, these two terms, they both have the variable x. I can factor out an x. Alright, so alright, so I've got this. Now, I can condense this as a single logarithm. Let's write log of 8 to the third power minus log, and I can rewrite this 1/4 as 2 to the negative 2. I can rewrite 8 as 2 to the third power, and then the 3 times 3, that 8 to the third power is the same thing as 2 to the ninth power. So let's see what we get here. as a single logarithm, my numerator is 2 to the 9th power. My denominator is 2 to the negative 2nd power. Well, see, I could jump to account. I'm trying to illustrate that this is going to eventually get to 10 over 9. Alright, so I've got log. If I bring that negative 5 up, I've got 1/4 to the negative 5. And the denominator here, I've got log of 2. And if I bring that negative up, the 9 minus a negative 2 is 11. And let's come over here. And I've got log of, if I flip this, I'll need to change that to a positive 5. And I've got 2 to the 11th. Now, I'm a little bit surprised that I don't immediately see how to get 10 over 11 out of this. I've got 2 squared and 2 times 5 to the 10th. And, oh yeah, okay, I see. And log 2 of 11. So by the power rule, this 10 comes down as a coefficient. This 11 comes down as a coefficient. And log of 2 divided by log of 2 is 1. So you can see we do get the same answer. Now, I didn't know when I started this that to illustrate that you would get the same answer, the second way is a lot longer, and definitely by using the logarithms, you really have to know the properties of logarithms very well. And I also had the advantage that I knew what I was trying to work towards. I knew that eventually it should get 10 over 11, so I didn't stop. I knew I could keep going when it felt, at times I was like, man, is this ever going to get there? What I was really thinking as I was doing this. Of course, I didn't say that while I was doing it, but that is what I was thinking. But I had confidence that it would eventually work to 10 over 9 if I hadn't made a silly mistake through there. So I hope that helps, and I'm going to continue the rest on another video.